So following the steps from the procedure we saw before, we get our standard deviation of this sample to be 13.842 when you round to the nearest thousandths place. So the steps, I found my n-1 value, I found the mean, we wrote which is step 1, we wrote out our table, which is step 2, we wrote down our data, which was step 3, that's all of those. We did the data minus the mean, that's step 4. We did the data minus the mean squared, that's step 5. We summed those together, which is step 6. We divided by n-1, which is step 7, and then we took the square root, which is step 8, and that gave us our answer. Just so you know, and just as a reminder, in the calculator, if you have the TI-30X2S, in order to do the square root, you have to click second and then the x squared, because above the x squared is where you see that square root symbol. So make sure you know how to calculate the square root, and then you just type in the value that you're evaluating. The standard deviation is going to be used in the next section when we look at the normal curve, because when we look at the normal curve, oftentimes we're trying to figure out what percent of the population lies between a certain number of standard deviations away from the mean. It helps us determine how the data varies from the mean. How far out are the values in the data set from the mean. The remaining questions on this guided notes is just for additional practice. Notice the number values aren't super big. I'm not giving you large data sets to practice with. It's just to check out what's actually happening. So I recommend that you attempt these problems and let me know if you have any questions and need any help. The last one I think is really interesting because we have a set where all the data values are the same. And I want you to think about what would happen. What would the standard deviation be for this set? So go ahead and attempt those problems. Email me if you have any questions, and I look forward to hearing from you if you need any help. Thank you.